Today we will learn the graphical representation of motion. So let's begin this.
Here is our first question on displacement time graph. Draw the displacement time graph for the following table which represents the motion of an object. Calculate its velocity. So, on the basis of this table, we have to make the graph between displacement and time. So, let's make it. Take this axis as the axis for displacement and this axis for time. Now give them the measures 1, 2, 3, and here 10, 20, 30, etc. Okay, now watch the table. When the time is 0, displacement is 0. Okay, at this point the time is 0 and the displacement is also 0. Next, when the time is 1, displacement is 10. Okay, watch here, the time is 1 and the displacement is 10. So meet them, we get this point. Now when the time is 2, the displacement is 20. The time is 2, displacement is 20. So meet them, we get this point. Okay, next thing, the time is 3 and the displacement is 30. So meet them, we get this point. Now meet all these points. So we get this graph. This is the displacement time graph for the table given. Now next thing we need to calculate is the velocity. Okay, we need to calculate the velocity. So how to calculate the velocity in case of displacement time graph? We have to calculate the slope. Okay, now what is slope? Watch here. Take this point as A, this point as B, and draw a triangle like this, and take this point as C. Now we need to calculate the velocity using this graph. So the slope of this graph will be, watch here, slope is height upon distance. This is the height and this is the distance. BC is the height upon AC is the distance, and this slope of the displacement type graph is velocity. The slope of the displacement time graph is velocity. So this slope we can write as V is equal to, now we need to put the value of BC. Watch here, at the point B the displacement is 30, at the point C the displacement is 10. So we place 30 minus 10 upon, watch AC, at the point A the time is 1, at the point C the time is 3. So AC will be 3 minus 1. Now solve this. 30 minus 10, this becomes 20, and here 3 minus 1, this becomes 2. So we have the velocity 20 upon 2. So this will be 2 tens are 20, or we can write it 10 meter per second. This is the answer. So we have calculated the velocity using this graph. Which graph? This is the graph which is according to the table given in this question.
Here is our another question on displacement time graph. Draw the displacement time graph for the following table which represents the motion of an object, and here the table is given. So we need to draw the displacement time graph.
Let's make it. So take this axis and this axis. Take this as the displacement axis and this as the axis for time. Now give the measures. This as 0, and in case of time that is given 0, 20, 30, 40. It means we need to take an interval of 10, 20, 30 and 40.
Now in case of displacement, look at the table. In case of displacement, it is given 0, 20, 20, 80. It means it is the multiple of 20.
So we need to make the multiple of 20. 0 plus 20 becomes 20, 20 plus 20 becomes 40, 40 plus 20 becomes 60, and 60 plus 20 becomes 80. Now
Watch the table again. When the time is 0, the displacement is 0.
it means this is that point where the displacement is 0 and time is also 0. This is the point.
Next thing, the displacement is 20 and the time is also 20.
So watch here, the displacement is 20 here and the time is 20 here. So meet them. We get this point.
Now next thing, when the displacement is 20, time is 30. It means
The displacement remains 20. The displacement remains 20, but the time becomes 30. This. So let's meet them. We get this point.
next, look again in the table. Displacement is 80 and the time is 40.
Displacement is 80. Watch here. The displacement is 80 and the time is 40, which is here. So let's meet them. We get this point. Now meet these points. We have started from here, then we moved here, and then we moved here. So this is the graph obtained with the help of this table. Okay, in the previous question, the graph that we have obtained was a straight line like this, but in this case this is not a straight line. This is moving here, then is moving like this. So we can differentiate between them. This is the graph where uniform velocity. In this case the velocity is uniform, but here the velocity is non-uniform. So when the graph is a straight line, the displacement time graph when is a straight line, then the velocity is uniform velocity and the motion is uniform motion. And when the graph is not a straight line, it is varying from the straight line, then the velocity will be non-uniform velocity. If the displacement time graph is not a straight line, then it requires the non-uniform velocity and the motion is called non-uniform motion. This is non-uniform motion. It acquires the non-uniform motion. In this case, that was uniform motion.
here is our first question on velocity time graph. Draw the velocity time graph for the following table which represents the motion of an object. Find its acceleration. So, with the help of this table given, we have to draw the velocity time graph and we need to find the acceleration with the help of the graph. So, let's make it. Take this axis and this axis. This let's take as velocity axis and this take as axis for time. So this is velocity time graph because this is the axis for velocity and this is the axis for time. Now give the measure, give this 0, this as 1, this as 2, this is 3 and this is 4. And here watch in the table. The table is given 0, 4, 8, 12. These are the multiples of 4. It means we can take the 4 as the multiple. 0 plus 4 as 4, 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16. Now look at the table again and we make the graph. When the velocity is 0, the time is 0, which is this point. Now when the velocity is 4, the time is 1. So velocity is 4 at this point and the time is 1 at this point. So meet them, we get this point. Next, look at the table again. The velocity is 8 and the time is 2. So the velocity is 8 over here and the time is 2 over here. So meet them. Now next thing, the velocity is 12, this, and the time is 3, this. So meet them. This is the point obtained. Now meet all these points. When we meet all these points, we get a straight line. So we need to find the acceleration. Okay, in case of velocity time graph, the slope is called acceleration. So we need to find the slope over here. So how to find the slope? Let's watch. Take this point as A and this point as B and make that triangle. Take this point as C. Now we need to find out the slope of this graph AB. So the slope will be height upon distance, that is BC upon AC. Okay, I have told you the slope of velocity time graph. The slope of velocity time graph is acceleration. The slope of velocity time graph is acceleration. So we can take this slope as A, that is acceleration, is equal to, now watch, we need to put the value of BC. Watch here. At the point B, the velocity is 12. At the point C, the velocity is 4. So this will be 12 minus 4 upon AC. At the point A, the time is 1. At the point C, the time is 3. So this will be 3 minus 1. So 12 minus 4. This becomes 8 upon 3 minus 1. This becomes 2. So 2 4s are 8. So we get the value of acceleration 4 meter per second square.
4 meter per second square. This is the required value that we need to calculate.
Here is another question on the velocity time graph. So this is, draw the velocity time graph for the following table which represents the motion of an object. Find the total displacement. So we need to make the graph, the velocity time graph, with the help of this table given, and we need to calculate the displacement in this case. So how to do this? Let's see. First of all, we need to make the graph.
So take the axis, take this as the axis for velocity and this as axis for time. Now give the measure, take this 0, 1, 2, 3, 4, and here 1, 2, 3, and 4.
Okay, now watch the table again. So this is the table. When time is 0, velocity is 4.
The time is 0 at this point, the velocity is 4 at this point. So meet them. When we meet them, it intersects at this point. So we get this point. This is the point where velocity is 4 and the time is 0. This is the point where velocity is 4 and time is 0.
Now next thing, the velocity is still 4 and the time is 2. Velocity is 4 and the time is 2.
Now meet them. So these intersect at this point. So we obtain this point.
Next, the time is 3, the velocity is 2.
So this is the point where time is 3 and the velocity is 2 at this point. The time is 3, velocity is 2. So meet them. We obtain this point.
Now the velocity becomes 0 when the time is 4.
Velocity is 0 and the time is 4. So meet them. When we meet them, it intersect at this point. This is the point of intersection. So we obtain this point, this point, this point, and this point. So let's meet them. Meet this with this, this with this, and this with this. So we have this graph.
Now what we need to calculate? We have drawn the graph for velocity time and now we need to calculate the displacement.
Listen, as I have told you in the previous question, the slope of velocity time graph is acceleration. But here we don't need to calculate the acceleration.
Here we need to calculate the
Displacement. So how to calculate the displacement? Let's see. Watch here. Here we have this graph, a straight line, and this line, which is falling down like this. And this is the separation between a rectangle and a triangle. Alright, so to calculate the displacement, we need to find out the area of these two surfaces, the area of the rectangle plus the area of triangle. So in case of velocity time graph, if we need to calculate the displacement, then we need to find out the area under the graph. Alright, In case of velocity time graph, when we need to calculate the displacement, we need to find the area under the graph. So under this graph there are two areas. One is rectangle, another is triangle. So we need to find out these area and sum them up to calculate the displacement. So let's calculate them. Take this as area A1 and this as area A2. So find out area A1. Watch here. This is a rectangle. The area of rectangle is length into breadth. So the length is this. This is the length, which is from 0 to 4. This is the length of the rectangle, which is from 0 to 4. 0 to 4 means 4 into breadth. Watch here. The breadth is 0 to 2. 0 to 2 means 2. So the area becomes 4 to the 8. So we have calculated A1 as 8. Now we need to calculate A2. The area of triangle is given as half base into height. Watch here. The base is this. Base is from 2 to 4. From 2 to 4. When this is from 2 to 4, we need to subtract 4 minus 2. 4 minus 2 becomes 2 into height. Height is this. Watch here. This is the height. And this height is equal to the height of this rectangle. Alright. The height of the rectangle was 0 to 4, which is 0 to 4 means 4. This 2 is cancelled by that 2 and we have the value of A2 as 4. Alright. So we have the value of A1 as 8 and the value of A2 as 4. Now we need to calculate the sum of these areas. The sum of these areas which are under the velocity time graph will be equal to the displacement. Alright. The area under the velocity time graph is equal to the displacement of the object. So let's sum them up to calculate the displacement. Displacement is equal to A1 plus A2. So watch here. The value of A1 is 8 and the value of A2 is 4. Put A1 as 8, A2 as 4. 8, 4. Sum them up, we get 8 plus 4, 12. And this is the value of displacement, 12 meter.
Now we need to prove the equations of motion with the help of graphical method. So we will prove the equation 1, which is v is equal to u plus at.
So watch here. Here is a velocity time graph. This is the axis for velocity and this is the axis for time. Velocity and time. So this is a velocity time graph in which the initial velocity is u, the final velocity is v, and the difference of them is v minus u. The time taken from O to R is t. Now watch here. This triangle. Here, this is the height and this is the distance. Height, distance. So In case of velocity time graph, the slope of velocity time graph is acceleration. The slope is height upon distance. Height upon distance is called slope, and the slope of velocity time graph is acceleration. So when we calculate the slope in case of velocity time graph, that will be acceleration. So calculate the slope. The slope here will be height, which is nq, upon distance, which is pq. All right, the slope of velocity time graph is acceleration, so we can take here as a is equal to nq. The value of nq is v minus u upon the value of pq is t. So we have this a is equal to v minus u upon t. This t multiplied with a, we get at is equal to v minus u. So we have at is equal to v minus u. Take this u to that side, we get u plus at is equal to v, and this can also be written as v is equal to u plus at, which is our first equation of motion, hence proved.
Now we need to prove the equation second, which is s is equal to ut plus half at square. So
Let's watch here. As we have proved the first equation of motion, which is v is equal to u plus at, we can also write it like v minus u is equal to at. Take this as equation 1. The value of v minus u is equal to at. Now come again with the same graph, with the same velocity time graph that we have used in deriving the first equation of motion. The same graph we are taking again. Okay, watch here. So this is our graph p to n. Okay, in the second equation of motion, which is s is equal to ut plus half at square, the second equation of motion is s is equal to ut plus half at square. S is displacement. It means we have to calculate the displacement over here. So how to calculate the displacement with the help of velocity time graph? The area under the velocity time graph is displacement. This is the velocity time graph. The area under the velocity time graph, two areas are here. One is this triangle and another is this rectangle. So we need to calculate the sum of these two areas. Let's take this as A1 and this as A2. We will calculate them and we will sum them up to calculate the displacement. Okay, so the area under this velocity time graph is displacement. So the displacement will be given as the sum of these two areas, A1 plus A2. So put the values of them. S is equal to A1. A1 is a rectangle. This A1 is a rectangle. The area of rectangle is length into breadth. Okay, so the length is t and the breadth is u. length is t, breadth is u. T into u, or we can write u into t, ut. Alright, plus a2, the value of a2. Watch here, a2 is a triangle. The area of the triangle is half base into height. Half base, base is this t, into height. The height is this. This is the height, and the value of this height is v minus u. The value of height is v minus u. Now calculate this s. S is equal to ut plus half t v minus u. Now take this ut as it is plus half t as it is. Now watch this v minus u. This v minus u. Watch here in the equation number 1. Watch here in the equation number 1, the value of v minus u is equal to 80. So from equation 1 we will put the value of v minus u as 80. So put the value of v minus u as 80. This is from equation 1. From equation 1. Now this becomes s is equal to ut plus half. Watch here, this t multiplies with this t becomes t square. So this becomes t into t square into a, t square a or at square. And this is our second equation of motion. Hence proved.
Now we need to prove the third equation of motion, which is v square is equal to u square plus 2as.
Okay, so as we have derived the first equation of motion, which is v is equal to u plus at. From this equation of motion we can write it v minus u is equal to at. From here the value of t will be v minus u upon a. Take this as equation 1. Now again take that graph, that velocity time graph. Again we are taking that velocity time graph, in which there is the graph which is representing the velocity time is Pn. Alright, so we will again calculate the displacement, which is the area under the graph, area under this graph. In the previous case we have calculated this as the sum of this triangle and this rectangle, but in proving the third equation of motion we will take the combination of these two, figures. This triangle and this rectangle combines to make a trapezium. Under this graph there is a trapezium. This is a trapezium, you can see here. Okay, so the displacement will be the area under this graph, and under this graph the area is a trapezium. So we will take the displacement is equal to area of trapezium. Alright, so How to calculate the area of trapezium? Watch here. The area of trapezium is half sum of parallel sides. Sum of parallel sides. Watch here. Parallel sides. This is a side, another side is this. So one side is this, another side is this, and these two sides are parallel sides of the trapezium. A trapezium has four sides. 1, 2, 3, 4. These two sides are not parallel, but these two sides are parallel. So the area of trapezium is the sum of parallel sides. This side has the measure u plus this side has the measure v. So the sum of parallel sides becomes u plus v into height. Height means distance between these two parallel sides. The area of trapezium is half sum of parallel sides into the distance between the parallel sides. This parallel side and this parallel side are at a distance this. This is the distance between these two parallel sides, and the measure of this side is t. So put here t. So we have s is equal to half u plus v into t. Now we will put the value of this t from equation 1. Watch here. This is our equation 1. Equation 1 says t is equal to v minus u upon a. The value of t is v minus u upon a. Put the value of this t in that expression. Here we will put the value of t from equation 1. Putting t from equation 1. So from equation 1 put the value of t. So this becomes s is equal to half u plus v, and the value of t is v minus u upon a. This is from the equation 1. So the value of t we are putting as v minus u upon a. So watch here. Take this 2 is in the denominator, this a is in the denominator. This 2 will be multiplied with this s, and this a will also be multiplied with this s. Means these are in the denominator, so this 2 and this a will be cross multiplied with this s. So this becomes 2as. 2as is equal to, now watch here, this is u plus v and this is v minus u. Okay, this u plus v can also be written as v plus u. We can write this u plus v as v plus u. So write it v plus u into this v minus u is also there. This a is already multiplied with this as, this 2 is already multiplied with this as, we have only this v minus u remaining. So take this v minus u which is remaining. Now watch here, v plus u, v minus u, v plus u into v minus u, this becomes v square minus u square, and this is 2as. Take this minus u square to that side, and we get u square plus 2as is equal to v square, and this can also be written as v square is equal to u square plus 2as, which is our third equation of motion. Hence proved.
That's all for now. See you again. Thank you.